In this lesson, we are going to discuss exponents. Essentially, we have just two quick objectives. We want to be able to evaluate an exponent, and we also want to use exponents to rewrite expressions involving repeated multiplication. Before you begin, you'll want to verify that you can multiply numbers, including a long string of numbers. As a time saver, you may do that multiplication just using a calculator. You should probably remember from your earlier classes that multiplication is repeated addition. If you take the same number and just add it over and over and over like I have shown here, this is what multiplication is. When we repeatedly add the 5 over and over and over, it's 5 times how many times it shows up. So for us, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This long string of addition is the same thing as 5 times 9. There is something similar with repeated multiplication. When you have repeated multiplication, that's what exponents are for. We are repeatedly multiplying 4 over and over, so that will be our number 4. And then we'll count how many of them there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And because there are 10, we will write it with an exponent. Just to emphasize that again, whenever we have repeated multiplications, the number that gets multiplied over and over is called the base. How many times is the exponent? One of the more common mistakes students have when they start working with these is that they'll treat 4 to the 10th power and they will say that the answer is 40. That 40 then is just taking 4 times 10, and that's not what this is. 4 times 10 is saying repeatedly add the numbers over and over and over, and that's not what we did. Our problem was not repeated addition, it was repeated multiplication. Make sure you don't make the mistake of thinking that this is just 4 times 10, because it's a completely different problem. It won't work that way. Now, the first type of piece that we want to do is to use an exponent to rewrite it. Well, since we repeatedly multiplied by 5, that's the base. And then you just have to count how many of them there are. 1, 2, 3, 4, 5, 6, 7. So we have an exponent of 7. Our directions asked us to rewrite. We're done. We were not asked to evaluate. We were not asked to actually crunch the numbers. The directions said to rewrite, so this is all we had to do. What about here? That's a base of 3, and because there are 2 of them, we have an exponent of 2. A base of 2 because it's repeatedly multiplied. 1, 2, 3, 4 of them, so we've got an exponent of 4. We're done. Base is 4. How many are there? 3. So an exponent of 3. The base is 5. The exponent is 4. Just quickly recognizing what gets repeatedly multiplied and then doing a fast count for how many of them there are. 9 to the 5th power. We're done. Now, we'll also have to pay attention to the directions, because the directions tell us, of course, what it is that we need to do. This one, these directions say find the value, so we actually need to crunch the numbers. We're recognizing that 3 squared is 3 times 3. There should be 2 of them. Now, we'd expect you to be able to take 3 times 3 and just know the fact that's 9. We'd expect that something like 2 to the 4th, 1, 2, 3, 4. We'd expect this is something that you could do by hand. 2 times 2 would give us 4. Another 2 times 2 is another 4. And we can build it downward, getting our answer of 16. With a lot of these, we'd expect that you would get them by hand. However, calculators do exist just to save us a little bit of time. One thing that we could do, 1, 2, 3, 4. There's our answer of 16. Calculators exist to save us some time. Go ahead and use them. What about here? 4 to the 3rd. All right, not writing it down because you just told me it's 4 times 4 times 4, which will give us our answer of 64. 5 to the 4th. 1, 2, 3, 4. Our answer is 625. 9 to the 5th. 1, 2, 3, 4, 5. 59,049. Again, the calculator is just a time saver. We still need to understand what this stuff is. We still need to understand that the exponents are repeated multiplication. That way we can count in the correct number, how many we were putting in. We also want to have an understanding of how these get used. For instance, how many cubes are showing up in this stack? We know that volume is length times width times height. And since we're looking at length, width, and height, which are all 3, length, width, and height, all we have to do is multiply it out. What's 3 times 3 times 3?
9.
3 times 3 would be 9. 9 times another 3. There would be 27 cubes in that stack. We'd also want to recognize exponents in a word problem format. For instance, there are 5 poets who write for a literary magazine. Okay, 5 poets. For an upcoming issue, they will each write 5 poems. If they're each writing 5 poems, that tells us that we'd have to multiply by 5. And at this point, we can continue reading, but there's nothing else going on with like each doing another 5 or another 5 or another 5. We're reading the problem, searching for how many times 5s they're looking for. On this one, we only had 2, so how many poems will be written? Just 5 times 5 equals 25 poems. And really, that's it. We're done. This shows us how exponents can be used in a simple context like poetry in a magazine, or how many boxes are stacked up over here.